I'm visible to everyone. Feel free to speak up, please.
Yeah, you are visible.
Yeah, you are.
Okay, okay. Yeah, thank you. Hi guys. Today is the day 2 of the Python bootcamp, the 7-day bootcamp that is. And I hope your day went well. My day was pretty boring actually. Um, can anyone remind me what we did yesterday? Feel free to speak up. Anyone, it's fine.
Some basics of Python up to strings, I guess.
Yep, you are right. We did some basics of Python and we discussed the conditional statement if else. Let's just quickly go over that. Let me share my screen. Is my screen visible to everyone?
Yeah. The IDs.
Okay, good. So we went over data types. Let me move this over here. Yeah, we went over data types. Numbers 1 plus 1 is 2. Wow. 1 times 3 is 3. 1 divided by 2 is 0.5. What data type is this? Anyone?
So,
Sorry?
Float.
Float. Yeah, you're right. This is float. And if the number of decimals here were twice the size, what would that data type be?
double.
Perfect. That would be a double. 2 star star 4. Any idea what the star star does?
Raised to the power.
Raised to the power of. Perfect. 4 divided by 2, that's modulo, that is floor division. It gives you the remainder, that is. Perfect. 5 divided by 2, sorry, modulo 2 is 1. 3 plus 6 divided by 4 times 2. Yesterday we had discussed that Python uses the PEMDAS rule, which is basically the BODMAS rule, but in a different language, apparently. Yeah, so it uses PEMDAS, which is basically parentheses of division, multiplication, addition, subtraction, I think. And it always follows that order of precedence. Sorry, it calculates the brackets first, and then it goes for division, multiplication, addition, subtraction, and so on. Therefore, you have your answer 1.125. Then we just saw how to name a variable. You can't start your variable names with. Sorry, was someone speaking? Okay. Yeah, you cannot start your variable name with a number or special characters, as it says here. This is a very simple concept that we went over, and this is just simple addition. Z is 5, 3 plus 2. Strings. We saw how we can name a string. I have no idea how I did this, but yes, we saw how we can name a string using single quotes, using double quotes, using wrapped quotes, single quotes inside double quotes, etc. We saw how to print, and we know what the print function does. We also know what the input function does. Is equal to input here. Sorry. Print. Oh yeah, I need to run this as well. Enter, enter, enter. There we go. I'm good. And now the value I am good has been put into the variable a. So if I were just to do this, it says I'm good. Why? Because I'm good, the text has been assigned to this variable a. Very simple topic. Let me just do this. And we saw how we can use the dot format system in order to print variables inside print statements. We can use this method or we can use this method. Just simply put curly braces and put dot format, and in that order, the variables will be printed. Are there any doubts so far? Anyone? Oops. You can feel free to speak up, guys. I won't bite. Sorry?
No doubt.
No doubts. Okay.
No.
One more thing. Two more things actually. Is there anyone in the meeting who had not attended yesterday's session and has just attended today's session? You can please raise your hand if you have. Pawan Kumar and Raga and Manicharan and all right. Okay, there are a few people. Okay, no problem. The slides and this video itself will be recorded and well, they were recorded from yesterday and I will be uploading them. They will be uploaded to the Machine Learning Club's official YouTube page. That link will also be sent to you people. Don't worry, guys. All of this material will be completely available to you. These PPTs and these code snippets as well will be available in a PDF file. Um, okay, to those who had not attended yesterday's session, I had given these people an assignment. Is there anyone who finished the assignment? One second. Just please drop your hands, everyone. Is there anyone who finished the assignment or has completed some part of it? You can just raise your hand, please. 2, 3, 4. Oh, a lot of people. Okay. Good. Okay. Fine. I will be going into how I wanted the assignment to be completed. It was a very simple assignment, just involved if else ladders and maybe some while conditions, and you had to use the keyword in. Can anyone remind me what the keyword in is? Just turn your mic on, please. Anyone?
Basically, it is used to check whether a particular item is present in a list or a sequence of certain items.
Perfect. That is the correct definition of in. Nice. So yes, in tells you whether a particular item is there in something. So, well, okay, wait. I have- Yes. So, here I had given a simple program. I said A equals input of hi, enter your name. What that does is it takes input from the user and it stores it into the variable A. Then it says print hello A. B is equal to input of how is your day going. So this input will be stored into B. Now, depending on what I put in B, what I put in this input, if it has the word hungry in it, it'll ask me to go eat. If it says not hungry, there's no need to eat. There's not. It says, oh, I'm sorry to hear that. Well, okay, this was a sample. Yeah, if it says not, maybe let's put not good. This is not good. Oh, I'm sorry to hear that. It's because like maybe your day is not going good. Okay. If it sees not good inside the statement that I put in, then it's going to say, oh, I'm sorry to hear that. And if it says thirsty, lol, go drink. Else, I'm not sure how to respond because this is an input that it does not understand because it is not in this set of instructions given. So I run this. Tiptoe, hello Tiptoe, how's your day going? Let's say I do not feel good. It does not sure how to respond because the phrase not good is not in it. Okay. So this was obviously it is extremely flawed. It was a simple project that I had given people. Not good. Oh, I'm sorry to hear that. It does as it's asked. It is a report after all. Yeah, someone has their hand raised. Shanton, what's up? Oh, it's been an accident then. Never mind. Ravindra, what's up? You need to speak up. I can't hear you, Ravindra. You can use the chat if you'd like. Shaurya Singh Chauhan as well.
Am I audible?
Yeah, you are audible. Shaurya.
Yeah, actually, in that assignment thing, I used dictionary responses, responses dictionary, and I didn't use any in function or something. So
Okay, that is
I
completely
actually made
fine.
three different chat bots.
chatbot.
So one of them is actually by using dictionaries. So is that fine?
That is completely fine. You can push it onto your GitHub, and there'll be Google Form sent to you people soon. And also to those who have not joined yesterday, who hadn't joined yesterday's meeting, please create your own GitHub account. There will be a Google Form shared soon, not only for this bootcamp, it will be useful for your future as well. So please create your GitHub accounts. Yeah. Yes. And sure, it's completely fine. All right. You did a good job, man. Yeah. So this is what we went through yesterday. We looked at booleans, we looked at comparison operators, and we saw the sep command in the print. We saw some if else statements. That's it. This is what we did yesterday. Okay. Now let us start with today's stuff. We're supposed to do, let me close these. Shoot, shoot, and shoot. Okay. Wait, now we need to start from lists. Yes. So what are lists? Lists are a data type within which you can store multiple small data types, regardless of their differences. You can store strings, you can store integers, you can store a list inside a list, etc. Now, the unique thing about a list is that you can change it. You can make changes to it. You can delete an element from a list. You can add an element into a list. You can alternate it however you'd want to. These types of data types are called mutable data types. Let me type it down. It's called, 1 second, create a new one. Mutable. There we go. Now, mutable data types, you have lists, which are a mutable data type. We also have dictionaries, which are mutable data type. Let's say dictionary. And immutable data types are ones that you cannot change. Here, I have tuple. Now, tuple is an immutable data type, which means once it is there, it is there. You cannot change it. Okay? Only thing you can do is probably delete it and create a new tuple, but that is it. Is that okay? Okay. So yes, you see a list here with only integers. Okay? We can access it too using indexing. We'll go through that later, I think. Yes. So hi 1, 1, 2. My list is equal to a comma b comma c. Let me delete this. Now my list dot append equal of t. Now can anyone tell me what dot append here does? So you can see here.
Adds DSL in that list.
Perfect. It adds d as an element. Now, what if I do add a cell below it, my underscore list dot, sorry, list dot append 3. Any idea what this will do? Will it append it or will it not?
It adds 3 to the list.
My list is not. Oh, oops, sorry. 1 second. 1, 2, 3, 4, 5, 6. Okay. Then I do my underscore list. Oh, it appended it twice because I ran the code twice. Yes. And yes, one more thing. The duplicate values are completely allowed in a list. Okay. You will see that won't be allowed in a dictionary because keys are unique values. But yes, duplicate values are completely allowed in a list. If I run this code again, it adds 3 again. Again, it will keep adding 3 because 3 itself, the weight of the value 3 is not defined as anything. For a list, it is just a thing that you need to add in its jhola. That's all it is. Now, my list of 0. Anyone that has learned programming before or any sort of, database, programming language or anything related to computers, you know that a computer starts counting not from 1 but from 0. We're looking at binary numbers as well. The two values that the computer can look at are 0 and 1. So a computer will always look at any such data type which involves multiple items inside it. It will always start counting from zero. For a computer, zero is one. So the first item you see in a list, it is referred to as index zero. The next item will be one. The next item will be two. The next item will be three. So if I say for a human being, a fourth item in a given list, it will be the third item for a computer. Okay, I hope that is understood. So my list of zero will give A, but if I do my list of five, any idea what this will give? I mean, obviously it's a lot of threes over here. So anything after three will be three, 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 three. Yeah, so it'll give you three. My list of one. Okay, let's see. Any idea what my list of minus one will give?
Three.
The last element.
Three.
Yes, you are correct. What about minus two then?
Again, three.
Okay. Well, minus one, two, three, four, five, minus six. Let's see, minus six. Any idea what this will give?
B.
You are correct. So when looking at a list like this, obviously, if this is zero, then इसके पीछे whatever comes behind this will be one. So A will be zero. Then minus one will be three. Minus two will be three. Minus three, four, five, six, seven, eight, nine. What if I do minus 10? Any guesses? Okay. It will be out of range.
Outrange.
Yes, correct. A list can only look at the number of elements that are in it. Now that can be from 0 to plus how many? 0, 1, 2, 3, 4, 5, 6, 7, 8. Plus 8 or minus 9. If I append this list one more time and do this, it will give me 8. Because then again, I have just entered the indexing range, correct? But if I do minus 11 again, it exits the index range. Therefore, it will give you an error. Okay, let's just do 10 and there we go. My list of 1 will give you B, my list of 1 colon. Okay, now the colon operator in tuples, this is, sorry, not tuples, list, my bad. But the colon symbol in lists is unique because it gives you everything after the given value. So you have 1, the index value 1, that is, everything after this will be printed. If you do colon before a given value, it will print everything before that given value. Okay, and that is why this uses indexes. It does not use particular values. If I were to put in this list everything below 3, everything before 3. Sorry, did someone have a doubt? Okay. um if I were to say I want to print everything before 3, the computer does not know which 3 na, because a list can allow multiple values. So if I said this 3 or this 3 or this 3 or this 3, the computer would get confused. It would obviously throw an error. Instead, we use index values. Now, if I do 0 colon, it says A, B, C, D, 3, 3, 3, 3. Now I do 1 colon, B, C, D, 3, 3, 3, 3. Sorry. I do 2 colon, C, D, 3, 3, 3, 3. 3 colon, and so on. Again, same thing. If I do it from A7, 6, 5, and so on. All right. So if colon is before your index value, everything before that index value will be printed. If it is after, everything after that index value will be printed. Okay. Also note one thing. This is index 0, this is 1, this is 2, this is 3, this is 4. When you're doing colon 5, everything before 5 is printed, but not 5 itself. But when you're doing 3 colon, 0, 1, 2, 3. 0, B, C, D. D has an index value 3. Sorry, was someone speaking? Okay, no problem. Yeah, D has an index value 3. Here you can see everything after 3 is also printed and 3 itself is also printed. This is one property of lists. When you're using the colon operator, if you want to print something after a given value, that value itself will also be included. If you want to print something before the value, that value will be omitted. I mean, you have to tally it somewhere, right? Either you print the value, everything after it, or everything before it, but you need to print that particular value somewhere, right? So you print it with everything after it. Are there any doubts so far? Excuse me. If there's no doubts, please turn your mic on and say no doubts. Anyone?
No.
No doubt.
Okay, thank you. Manaswani, do you have a doubt?
Yeah, can you repeat it again?
Sure, no problem. Isha, do you have a doubt as well?
Yeah, can I ask my doubt?
Yeah, go ahead.
If we are giving like 0 to 6, so it will print values 0 to 5, right?
0 to 5. So if
No, if
you
we are
want,
typing 0 to 6, then we get value 0 to 5.
do you mean like this? Sorry, 0 to 6. Do you mean like this?
Yeah.
0, 1, 2, 3, 4, 5. Yes, you are correct.
Okay.
Manaswani, yes. I will repeat this for you. Here, you're using the colon operator to print everything after the index value. Do you understand what an index value is, Manaswani?
Yeah.
Okay, thank you. So you know what an index value is, right? So this, everything, these are all assigned index values starting from 0, 1, 2, 3, so forth. So everything after the index value 3 is going to be printed here, including it itself, okay? And if I put the colon operator before the index value, everything before it will be printed, but this index value will be skipped. Is that understood, Manaswani? Do you have doubts? No?
Yeah, I understood that. Thank you.
Okay, no problem. So yes, this is a very simple thing. One second, let's go to the PPT actually. I wanted to show this. Learning the basics of Python and for some more padhai. I don't know why I put this here. I thought it was funny. Just delete it. Strings. This is something we did yesterday. Printing is something we did yesterday. Booleans, comparison operators. Okay, yes. Does anyone have any doubts in Booleans? We discussed this yesterday. Booleans and logical comparisons. If there's no doubts, please say so.
No doubts.
Okay.
No.
Thank you. Thank you. Chat. How long should we make? As long as you want it. It can be very short, it can be very long. It's up to you. Okay. This is a very rancid example that I've given. Comparison operators. Yes, this we've done. Logical operators, if, elif, else statements, loops. This is something we need to go through, but let us finish dictionaries and booleans and tuples and sets first. Okay. So does anyone have any doubts in lists?
No.
Okay, thank you. Also here, when you refer to an index value and you type in a new value, that value will get replaced. So if I were to run this and this, you see new is replaced. In place of A, now there's new. If I put something along the lines of list of 7 is equal to brr, and then I do my underscore list, you see the 7th index value has been replaced with brr. Okay. This is what we have. Nest equals 1, 2, 3 of 4 comma 5 comma target. How do you reach the target? So over here you have index values, right? 1 is assigned the index value 0. So let us create a new markdown over here. Yes. Now index, and we have value. Index value 0 will be assigned the value 1. 2 will be assigned the value 2. Sorry. 1 will be assigned the value 2. But 2 will be assigned the value 3. And index value 3 will be assigned the value 4 comma 5 comma. That understood? This list is assigned an index value. Now, in order to reach this target over here, what you have to do is you need to search the list within this list. How you do that is given right over here. You have nest. The third list in this will be this. And the second element, because 4 will be 0, 5 will be 1, and this will be 2. So the second element inside the third element will be your target. Is that understood, everyone?
Yep.
Okay, thank you. If
Yes,
there's any
bro.
doubts, please just feel free to interrupt me, okay? My chair is very creaky today. Annoying. Okay, let's go on to dictionaries. Now, dictionaries are a data type which are referred to by curly braces, okay? Tuples are referred by square brackets. Dictionaries are referred by curly braces. Ooh, curly. In dictionaries, you store items with a key value and its actual weight. All of you people have registration numbers now. You can look the same, you can talk the same, you can be twins and stuff. So people will look at, suppose, two identical twins in the college, and they won't be able to recognize who is who. Okay? They look at two twins and like, oh, hi Adi. Adi? Adi 1, Adi 2? They'll be confused. How do you recognize them individually? You look at their ID cards, you check their registration number. Iska hua 9991, iska hua 9992. So you know that they are different people. Okay? So similarly, in dictionaries, every value is assigned a key. Now, this key is like its own registration number. Two people cannot have the same registration number. Okay? Because we don't do identity theft over here. So here we have an example. D equals key, comma, like key colon item 1 and key colon item 2. Let's run this. There we go. Okay. Now key D of key 1 will give you item 1. Also, whenever you're searching for something in a dictionary, you use square braces. Let us replace key 1 with 1 and key 2 with 2. So if I do that, you see the number 1 has item 1 assigned to it. Number 2 is item 2 assigned to it. This is how you use dictionaries. I won't go into much details about this. It is just a simple data type that you need to remember. That is all, right? Now we go to Booleans. Booleans is something we did yesterday. It's very easy. Tuples. What are tuples? Can anyone tell me what a tuple is?
They are immutable.
Yes, they are immutable. So they're basically a data type. Okay, let us see. Tuples are basically lists, but you cannot change them. Another way that they are different from lists, sorry, similar to lists, is because they can allow duplicates. If I do T of 3 over here, will give me 3. It is the same as lists, but you cannot change them. You're okay, no, never mind. I can't use that example. Basically, Tuples, you can consider them to be people with a very conservative mindset. Okay. And lists are Gen Z. You can change them however you want them to change, you can make them look however you want them to look like. But tuples, you can never change them. Tuples are denoted by parentheses, and lists are denoted by square brackets. Okay. It's very simple. You can simply use them for indexing. And here I have tried to change the value of t of 0 to new. Since it is a tuple, झुकेगा नहीं साला. So, okay, let's move forward. We have sets after this. No doubts, I'm assuming. If there are doubts, please speak up, yeah? Okay, we go to sets. Sets are referred by curly braces as well, but how they're different from dictionaries is that they don't have a key value thing. Okay, we don't care about them. Other thing about sets is they do not allow duplicates. Regardless of how many values you put, how many counts of one you put, or two, like I just keep going. Sorry, I put a few two extra commas and boom, boom. You see, only the original values are posted. They don't care about how many copies of these there are, right? Only the original values will be posted once. Okay. Any doubts here? I'm not going into many details of how you use them, where you use them, because it's not relevant. We need to finish up with oops. The concepts of oops is what we have to do today. Any doubts here?
No doubts.
Okay, thank you.
No doubts.
Comparison operators, we've done them yesterday. Logic operators, if, elif statements as well. We've done these yesterday. Assuming there's no doubt here as well. Now we go to for loops. What are for loops? For loops are essentially for an item happening, for an event happening, do this. Okay. So as long as an item is having a value, it will execute, sorry, yeah, it will execute the following code. If that item has changed to a value that you don't want it to be, then you will stop executing the code. So here you can see SEQ is a sequence given here with 5 elements, 1, 2, 3, 4, 5. For item in SEQ, print item. So what for item is just one variable. So you've taken the variable and you've assigned it to 1. It sees 1. Is it an SEQ? Okay, it will print it. Then it sees 2. Is it an SEQ? Yes, it will print it. Then 3, then 4, then 5. After 5, it sees that anything else will lead to an out of bounds error. So it is just jumping out of the list. No, what is the point? Therefore, it will end the code right there. It prints the items here and then it stops the program. That is a for loop. Now, for item in SEQ, print yep. This prints yep how many ever times there is an item. So there is an item, it prints yep. If there is no item, it just stops printing. Okay. For jelly in SEQ, print jelly plus jelly. This is just, you can just replace this with item. Oh, whoops, sorry, I had to run this code. 1, 2, 3, and 4. What this does is you're basically printing twice the item. That's all you're doing. This code, you're printing twice of it. If I do star item, it prints the squares. If I do star star item, it prints the cubes. This is not a cube. 64. Yeah, it's 4 to the power 4, 3 to the power 3, or 2 to the power 2, or 1 to the power 1, whatever. Okay. I hope this is understood. Now, there's one more thing. You see the in command over here. In for loops, you can use something called range. Now, this range is what we'll go through here. For I in range 5, print I. What is this range? Can someone tell me what a range is in math? Just a basic definition will do.
Within the bounds.
It's like a
Within the bounds.
interval consisting of the start point and the end point.
Yes, correct. Kevin, do you have okay, you just wanted to answer. You don't have to raise your hand to answer, you just turn your mic on and speak, okay? And you are correct. It sees the start point and the end point, and it prints everything in between. Does it print the end point itself as well? No, it does not.
No, no.
Correct. So for I in range 5, print I. It prints 0 to 4. List of range 5. You're just converting the range 5 to list. Alternatively, you can also write 0, comma, right? And if I wanted to change the 0, comma 10, sorry, that gives you the same thing. And if I do 10 plus 1, gives you 10 plus 1. I hope this is understood. List comprehension. Okay. X is equal to 1, 2, 3, 4, simple list that you've made. Out is another list, but it's an empty list, okay? For item in X, now item variable will look at every data type inside this list. 1, 2, 3, 4. Out dot append item star star 2. What this does is it looks at every item and it squares it and it puts it in out. Print out. There we go. Oh, print out. Nice. 1, 4, 9, 16. This is your answer. But if I do 3, sorry, not 23. There we go. It will give you the cubes. If I do 4, it will push it to the power 4. That's a very simple example, okay? Item star star 2 for item in X. Yes, this is again the same thing, but you're just representing it in a single line. You always, when you're representing it in like a single line, you need to put them in square bases. Okay? This is the syntax. If I do item plus 52 for item X, this gives you numbers from 53, 54 to 56. I hope this is understood.
Yes, sir.
Yep.
Okay, thank you. Functions. Def my func param. Okay. These are functions, lambda expressions. You don't need lambda expressions actually. Leave this. Maps and filters. These are again under lambda expressions. Methods. Okay. I'm going to go through functions and methods. Now, what is this def? Def in Python refers to define. You are taking a variable name, a random variable that you've created, and you're defining it. You're giving it something more than just a data type. You're assigning a whole set of instructions to it. And that is called a function. Okay. Now you have your new function here called myfunc, and I've just put in a random parameter here called default. Okay. Whatever code you'd like to put here is going to go here, and at the end, it is going to print the given value. Myfunc is a function, but if you want to use the function, you use it with parentheses. Okay, just like every other function, you see the append function. Append, maybe you have these parentheses. These are all functions. Therefore, here as well, in a user-defined function, you always need to back it up with parentheses. I hope this is understood. Myfunc, and you create a new parameter here. This is a default parameter. But if you assign a new parameter while you're coding, it will program and it will code this. So if I do say my score func of hello, how are you doing? Oops, I keep forgetting to run the previous code. You see how it runs the function with the value hello, how are you doing? Prints it. This is a simple function for printing whatever value is given into it. Okay. Here is another function that I've defined. Def square of x, return x star star 2. And what this function does is pretty obvious. It returns the square of the number. If I change this to cube, oops, cube, and change this to 3. Any idea what the answer will be when I hit enter here?
Error
Error.
because there is no square function.
Oops, 1 second. Out is equal to square of 2. Oh, oops. Why will there be an error? Square brackets are used for this. I'm sorry, what did you guys say? There are no square brackets. Is that what you guys said?
I think the
No,
function
before
name
you did not
before
change the
No,
square into
before it
cube.
was square.
Oh,
function
yeah,
name
yeah.
was
Okay, okay.
different compared
Correct,
to
correct,
the
correct. I'm sorry. I heard square brackets for some reason. That is why. And yes, you are correct. The function name was not changed. Therefore, it was wrong. But if you put cube, it will give you the cube of the value. Yes, correct. It's just there we go. And that is it with this. Now let's go to methods. These are some default methods that Python offers you. You have, hello, my name is Sam. Sam is some random person. St.lower. You see the S capitalized here and it is lowered here. So st.lower will basically lowercase whatever you've written. Okay. st.upper, on the other hand, just converts everything to uppercase. st.split. Whatever your string will be here will be split into small space, like into individuals. Okay. And if I put st.split of e, it splits the string wherever it sees an e. First thing it sees is h. Uske baad it sees an e. Therefore, it splits h. And here the e is omitted. Then LLO space my space nam is taken. And again, this e is omitted. The rest just is Sam. There we go. Therefore, this is the output you get. Tweet equals go sports hashtag sports. Tweet.split hashtag. This removes the hashtag and splits the list, splits the string into wherever the assigned variable was. Right? This is another dictionary keys item. Oh yeah. Dictionary.keys will tell you what keys there are inside the dictionary. 1 second. Previously, I had mentioned, yes. Up here, I'd run a code for a dictionary with the keys 1 and 2. Now, without running this segment, you just forget the segment. You see the keys assigned in the previous dictionary were 1 and 2. And dictionary.items will tell you what items are related to those particular keys. Okay, it's that simple. List LST is a new list. The pop function will essentially just, sorry, lst.pop first, then pop again, and then pop from empty list. Does anyone know the concept of a stack?
yes.
Yes. So in data structures, a stack is a simple data type which basically you're stacking stuff. So I have these couple of coasters. I have an empty stack over here. Okay, right now my list is empty. I take one item, I put it on the list. Take another item, I put it on the list again. I take a third item, I put it on the list. What I'm doing here is I'm pushing values into the stack. Okay, I am pushing them. Now, similarly, you can just append them in a list. It's the same language, right? Now, what the dot pop function does is you take one from the top and you throw it away. You take another one from the top when the function is used and you throw it away. Finally, you take the last value and you throw it away. That is what the dot pop function does. That is why you saw the list go from 3, then it went to 2, then it went to 1. So let's run this code again. List.pop again will give me 3. Then I run it again, it gives me 2 because the last element has been already popped. So this is the last element. Now, if I do LSG, so removing this, you can see only 1 is left. And then I do list.pop again, and then I look at list, it is an empty list. I hope this is understood. This is just code. Okay. X in 1, comma 2, comma 3. X in X, comma Y, comma Z. This is you're just looking for values in a given list. This is understood, I hope. Okay.
Sir, can you repeat again?
Sorry. This or the list one? What do you want me to repeat?
Pop, sir, pop.
Pop. Okay. Okay.
I'll take it.
I threw one coaster behind, so I don't know how I'll get it. This is your list. You have items on it. Okay. What the pop function does is it takes the first item from the last index. So this is your last index value. The dot pop function, you will just take the last value and you will throw it away. Then your list is left with only this. This is gone. This is nowhere to be found. In a list of 1, 2, and 3, you have 1, then you have 2, then you have 3. Then you take 3, once I use the pop function once, you take 3 and you throw it away. All you have now is 1 and 2. Then you take 2 and you throw it away. And then all you have left is 1. You take 1 and you throw it away. Now all you have is an empty list. Okay? Jai Mata Di. I hope this is understood, by the way.
Thank you, Niyam.
Okay. No problem.
Thank you.
Damn. Okay. Let us continue with this. We finished all of this. Oops. Does anyone here know what oops is? The concept of
Object oriented.
okay, correct. And can you tell me what
Object-oriented
object-oriented?
programming.
Yes, and can you tell me what it is? What is object-oriented programming? Okay, I'll just continue to explain it. OOP refers to object-oriented programming, a type of programming which uses objects, classes, and functions all together to efficiently run the program. So you have, I explained this yesterday. In OOPS, let's consider the example given here. Legos. To make a big blocky Minecraft like man, you need to give the guy different body parts. You need to attach his legs, his hands, his body, and a head. Every part here has a separate purpose. The hands cannot do the purpose that the leg is intended to do. The head cannot do the purpose that the body is intended to do. Every part has its own use. Okay. So object-oriented programming mein, you have a program, you create several different small parts, and you attach them together to form one code, which works on its own using all of these individual parts. Okay. This is object-oriented programming. Each class and object has its own purpose. Perfect. Inheritance. You have your parents, they had their parents before that, and they had theirs. We are all the children of someone. This is philosophical. Let me remove this. Inheritance refers to a child class inheriting or claiming all of the properties of its parent class. So you have a parent class, you have your parents, and you have you. Now, your parents will keep some property for you people. No one else can access it. Unless you get bad marks or something, no one else can access your property. The property that is meant to be in your name is yours and yours only. Okay, no one else touches it. Therefore, this is inheritance. And there are multiple types of inheritance. What if you have a brother or a sister? Then your property will be touched by them also. Their property can be yours as well. What if you have children? Then your parents' property will become yours. Then your property will become your kids. So there are different types of inheritance, which I have mentioned here. They're not completely relevant to the concepts of machine learning particularly. This is just a skim through. There's multi-level inheritance, which is basically grandfather, father, son, uska son, uska son, and so on. Okay. Um, this is multi-level inheritance. This is multiple inheritance, where you have two parent classes, a mother, a father, and then you have one singular child class. Okay. You have single inheritance, which is the most simple of them all, one parent and one child. You have hierarchical inheritance, which is you have one parent and two or more children. Okay. Then you have hybrid inheritance. Hybrid inheritance is basically the mixture of everything. It is multiple inheritance, multi-level inheritance, hierarchical inheritance, whatever. You mix every single inheritance you find, you make a khichdi and you eat it. That is hybrid inheritance. I hope this is understood. I have code written down. I will go through it right now after I finish the concepts. Polymorphism. Think about a superhero who can change their powers depending on the situation. Sometimes they can fly like a bird, other times they're as strong as a giant, sometimes they're super fast like a cheetah, kind of like Beast Boy. I love Teen Titans Go, I'm sorry. Um, in Python, polymorphism is like that. It allows objects to be used in different ways. So one object can do different things depending on how it's used in the code, just like a superhero changing powers. So you have an object. An object has multiple methods. Like let's say a class. Like your class has multiple methods and multiple functions that you've made. Maybe you want to use one method or one function for one part of the code and another function for another part of the code. This is where polymorphism comes into play. What is polymorphism? It's literally the word says poly, which means many, and morphism, which means forms. Okay. So your one class, one object has multiple forms. You can use it in any way you like. Okay. I hope this is understood. Does anyone have a doubt in this? Just the theory part. I'll go through the code now. If not, please.
Bro,
Say
Yeah,
bro,
can you
bro,
please
yeah, bro.
repeat it?
Okay. Was I lagging or something? Is there any issue with my internet?
Lagging, bro.
Lagging.
More
Okay,
much lagging, bro. You are on lagging.
hold up. Um, okay, I hope I'm audible, but you can still see my screen, yes? Um, you want me to repeat polymorphism?
Yes, bro.
Okay, okay. So you have one code, okay? Now in your code, you can have multiple methods, multiple forms where you need the code in different ways. Now you have a class, and in your class you have different methods. Now one part of the code uses one method, but the other part of the code uses a different method. This is where polymorphism comes into play. You are using literally your class in many ways in different places. Okay. So basically, it has many faces. That's all you can think about it. It's a simple explanation. When you see the code, you'll understand. Okay. I hope that's okay for now.
Okay.
Yeah.
Hello.
Yeah.
I just wanted to know, like, just like Java, like, does Python support any kind of like overloading and overriding things?
Yes. Function overloading and function overriding are things in Python, just like in Java. I have not created examples for that. But because you don't particularly need to know the details of that, but I will share a PPT with function overloading and function overriding examples given in them. Okay. Look, this is Arnab, yeah, Arnab Mondal, yeah. Okay, let us look at the code. Okay, so here from yesterday's assignment that I've given, I created a small chatbot, like very tiny, obviously, which is an example. Okay. From datetime import datetime is something I did by myself, and A is an empty list. Now you're using a while loop. What I've done here is while exit or quit, not in A. So initially A is an empty string. So exit or quit is not in A, obviously. A equals input of, hey, how can I help you today? Whatever. Say exit or quit to leave. To follow this up, over here, I have put exit or quit, and it breaks the code. This break keyword, what it does is it leaves the while loop and it exits the code. Is that understood? I will share this example later, but let me just show you how it works. I say, hello, hi back. You see this thing, it will keep going. A equals input. As long as exit or quit is not read, it will keep running the code. Let's say I am hungry. You can try eating something. I am thirsty. Try having some water. Can you tell me the time? The time is the date and the time. Okay, that's what it does. And finally, if I do exit or if I do quit, it exits the program. Okay, I'm going to leave I'm going to leave this link to you people soon. Now you look at a class. What is a class? A class is a collection of objects. That's all you have to understand from class, as a collection of objects. That's it. Okay. You have multiple objects here. You have a equals 2, which is a variable, b equals 3, which is a variable, c equals 0, which is a variable. They're all members of the class hello. Now, when I've come out of this class, I've created an object for this class hello. I'm calling it h. You can so call it hi if you wanted to. Okay. Now you do print hi.p, print hi.a, then you do hi dot, oh god. Okay, you did this. Then I do hi.c equals hi.a plus hi.b. Okay, this is something I've done. Now, what will happen here? Can anyone tell me what the value of hi.c will be?
Five.
Yeah, there we go. Value of hi.c will be 5. Now the hi.b is 3, a is 2, and c is a plus b, which is 5. Now here, clearly you can access the class hello. Okay. What is a constructor? A constructor essentially constructs the members of a class. That is the most simple definition, as easy as it gets. The self keyword over here, you're just basically you're saying, okay, yeah, the def in it as well. I need to go through that. Start from the beginning. Class square. Very simple. I've named a class, the name square. Then I've done def init self comma num. Self dot num equals num, print num star star num. Sq equal to square of 3 sq. 1 second. Num star star 2. There we go. Okay. Now, what is this def init? Def refers to define, but init refers to initialize. So what you're doing is you're initializing a particular variable. Num is what you're initializing. Self is a keyword again. You're doing self dot num equals num. So you're telling this class that num is a number that I'm assigning to yourself. Num is a variable that I'm assigning to you. So wherever outside this code you're using a variable over here, you need to print num star star 2. Obviously, num has to be an integer. If it is a string, you will have an error. Why? Because you can't find the power of a. Okay, 2. There we go. I hope this is understood. Def underscore init. Does anyone have a doubt here?
Yeah, it's clear.
Okay, good. This is as simple as it gets. A class and its constructor. You're assigning it a value. There we go. Let's say I want the square of 8. I will get 64. Perfect. Now, an example of the constructor concept. Let's say a man. A man has limbs. A man does not have a trunk, and the gender of a man would be M. Then I've initialized this using a constructor and given him a name. Okay. Say a woman. Woman has limbs. Yes. Woman does not have a trunk, obviously. and the gender assigned is F, def init, and I've given it a name, her a name, sorry. Then I have an elephant. Limbs, yes, trunk equals true. You see how here I've put no and here I've put true. It does not matter because these classes are not linked to each other, but I can also put yes over here if I'd like to. Then I assign them names with a constructor. I say Deepa equals woman of Deepa, Tipto is equal to man of Tipto, Rahi equals woman of Rahi, and Dumbo equals elephant of Dumbo. Does Tipto have limbs? Dot format Tipto dot underscore class underscore dot limbs. What is this underscore underscore class underscore underscore? Let us show you by Tipto. You see yes come out. So basically, the class with that Dipto belongs to. What class does Dipto belong to? Dipto belongs to man class, right? Now we got to see the value limbs over here. And the value of limbs is yes, I do have limbs. Now this is the same as man.limbs. Because I know the name of the class, I can simply put man.limbs. But I wanted to specify, does Dipto himself have limbs? That is all I wanted to specify. So I can use the underscore underscore class method. All right. Does Rahi have a trunk? Does Deepa have a trunk? No. What gender is Dipto? What gender is Rahi? MF. Oh wow, MF. Does Dumbo have a trunk? And you see that this shows yes. Alternatively, if I remove yes from over here and I put in true, which is a Boolean value. Oh, sorry. It gives me the value true. Does Dumbo have a trunk? True. And this code is pretty self-explanatory. I hope I don't have to explain this further. Are there any doubts here? Guys, I hope there's no doubts. Okay. Inheritance. You saw here that inheritance has multiple types: multi-level, multiple, single, hierarchical, and hybrid inheritance. Now we're just going to look at single level and multi-level inheritance for now. Okay. Inheritances, you have a crayon, you've given it a color, right? And now here's another method, draw of self. Print drawing in self.color. Okay, 1 second, sorry. This is format of, no? Yeah, correct. So what I'm doing here is this F is basically format of, and in these curly braces, it shows self.color, which is a color defined over here. Now later, whenever I bring the crayon method, I can assign it a color. So I create a regular crayon is equal to crayon of blue, and regular crayon dot draw will say drawing in blue. Another crayon, which is a super crayon. Let's say we have a super crayon which can draw in any color that you assign it. Okay, you can draw it in any color, and it has a special ability, it glows in the dark. So you have class of super crayon which inherits this value. Whenever you want to inherit something, you simply create class of mega crayon of crayon. What this does is def blow up of self. Say print I'm blowing up. Boom. Okay. Now I create MC is equal to mega crayon of yellow. What I can do here now is I can do mc.draw, and I can do mc.blow up. You see it is drawing in yellow and then it is blowing up. So what I've done here is simply I have put in the crayon in parenthesis after the class name, which inherits every property of the class crayon, regardless of whether it is the draw ability, and this is just the constructor. Whatever other ability I put in here, the mega crayon will inherit it, or the super crayon will inherit it, because they are child classes. They are inheriting all the properties of their parent classes. Is that understood? Are there any doubts here? Guys, I'm waiting for someone to speak up, please.
Yeah, it's
No
clear.
doubts.
It is clear, please. Thank you. Um, Finally, we have single level inheritance. Here it is a very simple explanation. You have a class animal which makes a sound, and pass is a keyword which accepts whatever code has come before it, and it continues on to the next code. Similarly, there's another keyword called continue, which accepts every code and follows onwards to the next following code. Like if I do some gibberish after this, continue will continue through all of these lines of code. But pass will simply skip through all of this and go to the next part of code. Okay, that's a very simple thing. So I've put pass over here. Now I've put class dog, which inherits animal, make sound of self, return woof. Now return, I hope what return is, I hope you people know what return is. It basically returns the value. It prints whatever value you've put in here. And you can always use return as long as it is with a function. You cannot use return outside of a function. Okay. Now dog equals dog, print dog dot make sound, woof. Let's create another animal, class cat of animal. Okay, so it inherits all the properties of animal, def, make, or sound, self. Return meow. Now I'm going to create an object. Cat is equal to, wait, no, 1 second. Class name cannot be the same as the object name. Please remember this. Cat equals cat of this, and print dog dot make, sorry, cat dot make sound. You see, this method, def make sound, is a common method everywhere. And this cat and dog thing, it is inheriting, both are inheriting animal. I'm sorry. Both of these classes are inheriting all the values that animal has to hold. Therefore, you have woof and you have meow. Now you have multiple inheritance. Flyable, def fly self. Duck can fly. Swimmable, a duck can swim. Duck of flyable, comma swimmable, pass. What this is, you've created two classes and you have made one singular class that inherits both these values. So you have A, you have B, and you have C, which inherits both A and B. This is multiple inheritance, as you can see here. You have a father and a mother and a son. Flying is the father, swimming is the mother, and duck is the son of flying and swimming. Okay? If this isn't understood, multi-level is basically like a ladder. You have one father, one grandfather, then you have a father, then you have a son. Here, similarly, you have class animal, which makes a sound. Then you have dog, which represents animal, and it returns woof. And then you have bulldog, which brings through all the variables possible in dog, and it returns running like a bulldog, whatever. So you can see the code run. You have woof first from the dog class over here, and you have running like a bulldog, because that is the run method over here. Okay. Run is something only bulldog can access. Animal cannot access run. Dog cannot access run. Okay. Is this understood by everyone?
Yes.
Okay. Okay, okay. Thank you. Finally, we have polymorphism, and this is the final topic for today. Um, you have class shape, you have defined area of self, then you have class circle of shape, and you have a constructor over here. I hope you guys understand what a constructor is now. You're just assigning radius to the circle. That is it, okay? And another method, area of self, return 3.14. What is 3.14? Pi times radius times radius. This formula is obviously pi r square, which gives you the area of a circle. Then you have another shape, a square. This inherits every property from shape again. And you have, obviously, you're initializing the side over here using a constructor. And you have the same named method, area. Returns self.side times self.side. That's basically length into breadth. Or, wait, sorry, it's a square. So, side squared. This is an example of polymorphism, where one object is used in multiple ways in multiple scenarios. You have your method area, and you're using it in a different way in class circle, and you're using it in a different way in class square. It's as simple as that. Polymorphism does not get any simpler. Circle equals circle of 5. You've created an object called circle. Let's change this to C and S for ease. Shapes is C and S. You've just simply created a list called shapes, and you've put the values of C and S in this. For shape and shapes, print area colon shape dot area. Okay. What this does is it simply prints it in the order of the list available. Is this code understood? I will be sharing all of this code with you people. Don't worry. But is this code understood?
Can you explain it again?
Yes.
Okay, you want another explanation? No problem. Did you understand when I created this parent class shape?
Yes.
Okay, Mihir, right? What's your name?
Soumyadeep.
Oh, sorry, I'm very sorry. Soumyadeep, perfect. Soumyadeep, now you have the class shape. Now you've taken circle as a class, which inherits every property of shape. And you've created a method over here called area. You understood this? And here you've initialized using a constructor. You've assigned the value of radius to the class over here, okay? Is this much understood?
Yeah.
Okay. Now you're using the same method over here, def area. You're using the same thing, except for every class that you're creating, you're returning something different. Okay. For square, you're returning side dot side, side times side. For circle, you're returning self dot radius dot radius. Basically, you're using one method, but in two different ways in two different situations. That is polymorphism for you. Do you understand this?
Yeah.
Okay. Guys, are there any doubts in anything in the concepts of OOPS? Obviously, I know I've skimmed through a lot of the stuff, but they are not relevant as much. Therefore, skim through them. Okay, one more thing. I have some exercises set up for you people. I will be sending these to you, and I would like you to go through these and have the answers ready by tomorrow. We'll discuss them in class tomorrow.